guys, this is Mrs. Maurer from downstairs again. I'm trying to get your physics class and your physics content delivered to you today. So I've recorded this podcast. As you can see, I'm at home. School's out, and trying to take care of some things so that we can make sure that you at least have a lesson for today. Today I want you to start the class off with this bell ringer. It's for September 20th and 21st. Go ahead and take out your physics notebooks. And I want you to look at your notes from last class. And half of the classes got a study guide, half of them didn't. So just look in your notes, whichever version you have. And I want you to write down the equation for displacement that we talked about last class. I want you to think about the concepts that we talked about. How does displacement differ from total distance? Third question, how does a vector quantity differ from a scalar quantity? And then I want you to calculate two problems. Yes, you can use your cell phone calculators. First question says, if a car begins 20 meters away from you and stops 50 meters away, what is its total displacement? So my hint for you is make sure that you define where the zero is and in your relativity. Draw your number line and then go ahead and use your displacement equation that you looked up from your notes in number 1. Second question is a two-part question. It says calculate if a car begins 20 meters away from you and turns 50 meters away, then travels the other direction 10 meters, what is the total distance traveled? And so this is like the last example that we saw in our slides in class last time. So make sure that you take a moment to draw out two traveling things on your number line before you calculate it. Usually if you draw the picture in physics, you'll do a lot better. So let's go ahead and pause this, give you about 7 minutes to keep going. Alright, so let's get going on with the other topics for today. Today our topics are going to be velocity. You might have heard the term talked about as terms of speed, but we're going to talk about velocity and we're going to talk about the graphs and how velocity, time, and position all relate in graphing. Okay? So first thing you need to know that the change of time is very, very similar to the change of displacement. The equation is delta t, which is change of time, equals the final time minus the initial time. So t sub f minus t sub 0 aught. So make sure you have that in your notes, put it in the study guide, or write it in your notebook. A lot of times, t sub aught, or which is we call the initial time, is set at 0. If you turn on your stopwatch and don't click it, 0 is where we're going to start. So delta t equals the final time, which equals time. So that's why you could time it with a stopwatch. Okay? I'm just kind of let you know that time is very, very important in doing this. So in order to calculate velocity, we would need to know the change of displacement, so delta x from last class, and now we know delta t. So graphs are really useful in helping us do this, okay? The slope of a position versus time graph, which is what we've got going right here, displacement and time, is going to tell us the velocity. And it is true that most of the time your velocity would change. If you were to sit there and measure yourself driving home from Tooele High or something like that, yes, the time would physically be changing. And so that's something to think about and something to consider, okay? So now that it changes, the way that we calculate it is using the line slope. And you can see if we were to plot it, this is actually a curved line. If you were using calculus, you could actually fit the curve, and then you would use a function equation in here. But in general physics, we just use algebra as our expression and use smaller segments to model our numbers. Ooh, that was a mouthful. So this is what the equations that you need. Velocity is the rate of change of position. So v equals the initial position minus, I'm saying again, velocity is the final position minus the initial position. So again, stop minus start. Velocity is divided by the time, which is the final time minus the initial time. And so again, we're looking at subtracting 0 again for most applications. We can actually use this is the slope of a line equation. And we actually can use this to calculate position of a place in time. So position x equals velocity times time plus the initial position x of 0. If it's the origin, then we can just go ahead and drop that. If the graph is not a straight line, which is what we've got going on in this particular diagram, you can actually draw the slope of a line tangent to that point of information that you're looking for and calculate it that way. And that's what these little black lines are next to the red lines. These are the tangents that you need. So go ahead, get those in your notes. If you need to pause it, recording, please do so you can catch up and make sure these are completed in your study guide. All right, so a quick reminder from last class that should be in your notes, but just make sure. Velocity is a vector. Vectors, remember, they're like Victor from Despicable Me. It has magnitude and direction. Okay, magnitude is the number quality and direction is the place that it's going. Velocity always is a vector. And remember, velocity equals displacement divided by time. I like to take a moment and think about my physics equations and put them in word form. And I encourage you to do that right now in your notes. The reasoning is that algebra is simply a tool to solve these problems. And when I studied mechanical engineering, we used algebra to solve the problems. Then we went and we learned how to solve the problems using calculus. And then we went and learned how to program these questions into a computer program so that the computer would solve all our problems for us. And so at that point, you actually need to understand that this is a statement to memorize of a physical science concept instead of just simply being an equation in algebra to memorize. Okay. So just when you're going through trying to memorize it, think of it in terms of words. Velocity is the displacement divided by time. Speed is a little bit different from velocity. Speed is a scalar quantity. It has no direction. And velocity is simply distance divided by time when it is speed. Both of them are units in meters per second. Most of the time in physics class we will talk about velocity because we are looking at problems such as a car traveling east going this in this direction instead of just the numbers read off of your speedometer. Okay? So velocity and time graphs, they're kind of interesting. The graph in this picture shows the height of a ball thrown straight up as it travels versus time. So this was in the air for 9 seconds. That's a pretty good throw. But I didn't go very high. I only went 4.5 centimeters in the air, so it's not very high. And they want us to find the velocity of the ball at 2 seconds. So we're going to use our velocity equation. Velocity equals position final minus position initial divided by the end time the 2 second time minus the initial time. So we're going to look at our graph. X is actually over here. And we're going to go up here and look off of our tangent slope. We're at 4.2 centimeters. And the bottom of our tangent slope is down here at 1.7 centimeters at 1 second. So we're going to write 4.2 centimeters divided by minus 1.7 centimeters. And then we're going to divide it by 3 seconds. Subtract 1 second, and we can see that the velocity of the ball at this point of its trajectory is 1.3 centimeters per second. Interesting thing about this graph is this is where gravity takes over, and the balls actually slow down when they get to the top, and then they speed back up as they come towards the ground. Just like the initial throw was going to have more velocity or more speed than it would at this point in the middle. So please make sure to copy down this example problem in your notes. Make sure you've got it all right because you will need to use this example to solve some problems later on today. This is a sketch of a graph of velocity versus time, which is interesting because we can actually take position here and time, and is really interesting. Okay, hold on, I'm going to pause. Okay, so this slide is actually a practice problem. Okay, part A says sketch a graph of velocity versus time corresponding to the graph of displacement versus time given in the particular graph. So I don't want you to do part A, so just go ahead and skip that. Look at this graph, and I think part B is useful for us to practice. Identify the times at which A, B, and C are where the velocity is the greatest. So if we're going to look at this graph, we've got the greatest amount of position divided by the least amount of time, smaller amount of position divided by time, or the smallest. So I would say at this point A is the place where the velocity is the greatest. Okay? We really don't know where the time is 0 because we don't have we don't have a velocity equals 0 because we don't have anything actually starting at time 0. And it is negative when the slope is going back down. So E, F, and G is where we've got some negative slope. So that would be the answer to D. So just make sure that you kind of have some of those answers in your notes. That's just a quick view of that topic. And we're going to go on now. Alright, so here's an example problem. The spine-tailed swift is the fastest bird in powered flight. On one flight of a particular bird flies 306 miles east, then turns around and travels 405 miles back west. So that sounds like our displacement equations, doesn't it? This flight takes 15 seconds. What is the average velocity? So first thing we're going to do, velocity is change in displacement divided by change of time. So here we really are just using our displacement equation that we used from last class. We've got 306 meters minus 406.5 meters. We're going to divide it by 15 seconds because our initial time is at 0. And we're going to get negative 6.7 meters per second. So the negative sign means that it's going to be going west instead of east. Average speed is what we calculate. You would need calculus to do instantaneous speed. And so here our velocity is simply distance divided by time. So average speed is 306 plus 406.5. Add it together and divide it by 15, which is 47.5. So you're going, wait a minute. What is the difference here? So the first question is average velocity. The second question is average speed. And so remember, we've got a vector quantity here, so direction is important. Remember down here, speed is not, and that's why we just have a regular number, okay? So which would you use to say how fast the bird is traveling? It is average speed. Okay, so that should be the end of today. Make sure to do some of those practice problems on the back of your worksheet. Come on downstairs and talk to me after school Monday, Tuesday, or Wednesday, and I can help you solve any of those problems that you need help with. Have a lovely day.